In order to process the data should be organized in a particular way. This leads to a structuring of data. Data structure means organization or structuring a collection of data items in appropriate form so as to improve the efficiency of storing and processing. A data structure is a specialized format for organizing and storing the data. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start discussion about the data structure. It is the new chapter, chapter 4, data structure. Now, the weightage of the chapter is total 14 marks and 4 questions. MCQ 1 question, 1 mark, and 3 marks, 1 question, 3 marks, and 5 marks, 2 questions, 10 marks. Together there are 4 questions with 14 marks. It is an important chapter for the examination is concerned. In this chapter, we are going to cover these topics here: introduction to data structure and definition of data structure and types of data structures. And as a data structure, we are going to study arrays, stack, queue, linked list, trees, and graphs. These are the topics to be covered in this chapter, data structure. Let us see what is data structure. First of all, you know what is data. Data is nothing but a raw fact. That is before processing. After processing, that is information. And before processing, it is called data. It is a raw fact. So, these data have to be processed to form information. Fine. In order to process the data should be organized in a particular way. This leads to a structuring of data. So, for effective data processing system, we have to keep the data or we have to store the data in a memory effectively. So, the meaning is that these data has to be structured, or we have to store the data in a memory in a proper way. That is data structure. So, utilization of space by the data in the memory and optimization of time taken for processing plays an important role in data structure. And what is the advantage of this? Here, it is for efficient data processing. The data in a memory, it has to be stored in a such a way that the utilization of space, it should be effective. I mean, the amount of space in the computer memory, it has to be used effectively or utilized properly. And time taken for processing the data, it is also very important point to be considered. Data structure or efficient way to organize the data. And we have to organize the data in a computer memory for effective data processing. So, what is a data structure? It is a method of organizing data in a computer memory. Now, data structure means organization or structuring a collection of data items in appropriate form so as to improve the efficiency of storing and processing. That's what I have told you just now. So, for effective utilization of computer memory, and for effective computer data processing, it is necessary for us to store the data in a computer memory in data structures. Now, let us see the classification of data structure. Here the definition. A data structure is a specialized format for organizing and storing the data. That is what the definition is. Now, let us see the classification of this data structure. Mainly, data structure are of 2 types. One is primitive data structure and non-primitive data structure. Under primitive, we have integer, floating point, character, pointers are the primitive data structure, and non-primitive data structures are arrays, lists, and files. And under arrays, we have single dimensional array, 2-dimensional and multi-dimensional arrays. Under list, we have linear data structure and non-linear data structure. Under linear, we have stack, queues, and linked list. And non-linear, trees and graphs are example for non-linear data structure. So by looking at this schematic diagram, we can easily make out the different types of data structure with example. Now let us move on to the next slide. Let us see the definition of primitive data structure. So what is primitive data structure? These are directly operated upon by machine level instructions and are known as primitive data structures. These are predefined or existing data structures and operated upon machine level language. Examples are integer, real or float, logical data, character, pointers, and references are primitive data structures. Now let us see what is non-primitive data structure. Non-primitive data structures are more complex data structures. These data structures are derived from the primitive data structures. They stress on formation of groups of homogeneous and heterogeneous data elements. So what is non-primitive data structure? And these are the data structures are formed by primitive data structure. These are data structures are constructed with the help of primitive data structures. And non-primitive data structures are classified as arrays, lists, and files. Here, arrays, lists, and files are examples for non-primitive data structure. Now, let us see what are all the operations on primitive data structures. Now, what you have learned is, in previous slide, we have learned primitive and non-primitive data structures, and primitive data structures are integers, float, character, and so on. So here, what are the operations performed on primitive data structures? The various operations are, first one is create. What is create? Create operation is used to create a new data structure. So first of all, the first operation is create. See, we have to create data structure. How it is possible? This is example int x. Here int is a data type, x is a variable or identifier. So int x, if you use the syntax here, is going to create one data structure. So this is create. This operation reserves memory space for the program elements. It can be carried out at the compile time and runtime. So what is the create? Create operation is nothing but creating a new data structure, means is going to reserve amount of space in computer memory for processing. So this is create, one operation. Next operation is destroy. Destroy operation is used to destroy or remove the data structures from the memory space. So what is the meaning of destroy? Here, once the data structure is created, so it will be there in the computer memory for long time. So once after making use of these data structures effectively, then it is a very good practice to remove the data from the computer memory or to erase the data, to delete the data from the memory. So for that we are using destroy operation. It is used to remove or destroy the space allotted for particular data structure. This is destroy operation. Next one is select. Select operation is used by programmers to access the data within the data structure. This operation updates or alters the data. So next operation is select. What is the meaning of select here? Selecting a particular element, particular data within a system or within a data structure. So we have to select a particular data or particular value data structure for updates or alter the data. So in case if it necessary to change the values of any variables or values of the data in the data structure, we can make use of this select operation. Update operation. Update operation is used to change the data of data structures. An assignment operation is a good example for update operation. What is update? Here, update operation is used to change the data within a data structure. For example, in the example here, int x equal to 2. This is create operation. What you have seen just now, int x is create operation. It's going to create a data structure. And here x equal to is a value given here. So here 2 is a constant assigned to a variable x. So this is a data structure. So suppose in case we want to update it. So what is the meaning of that? Next, if I say x equal to 4, here value of x equal to 2. And here if I say value of x equal to 4, then the 4 is the value. It is reassigned to x. The value of x is 4. So here the value of x we have updated from 2 to 4. This is update operation. Now let us move on to next slide. Here, linear data structure. Now let us see what are linear data structures. Linear data structures are a kind of data structures that has homogeneous elements. Each element is referred by an index. The linear data structures are stack, queues, and linked list. So here we are going to learn the definition of linear data structure. Here, what are linear data structures? It is a group of elements of homogeneous elements. It is what the meaning of homogeneous elements? It is nothing but a data items of one particular data type. For example, if it is int data type, all the elements should be of the data type int. Suppose if there is a float data type, so all the elements in a data structure must be of float data type. That is the meaning of a homogeneous elements. And how do we refer all the elements? In this example, in linear data structure, we are going to refer all the elements by the index. And examples are stack, queues, and linked list are the example for linear data structure. Next definition is non-linear data structure. What is non-linear data structure? It is a data structure in which the data items is connected to several other data items. So here, if you have seen the previous example, linear data structure means there is a link from, or there is a connectivity from one data item to another data items, or all the data items are stored in continuous or with the continuous index number. But whereas in non-linear data structure, here data items are connected to several other data items. Means the meaning is there is no definite order to store the data in non-linear data structure. Trees and graphs are example for non-linear data structure. Next one is operations on linear data structure. Now what are linear data structure? Here all the data items are arranged continuously in the definite order. So here what are the operations can be performed on linear data structure? One is traversal. The definition is the process of accessing each data item exactly once to perform some operation is called traversal or traversing. Means suppose in a data structure, if there are 10 data items, so all 10 data items must be accessed at least once. That is the meaning of traversal. So we can access those data structure at least once for different operations like select operation, update operation, alter operation. So any operations can be performed after selecting particular data element. So here traversal is nothing but accessing each data item in a data structure at least once. Next one is insertion operation. The process of adding a new data item into the given collection of data item is called insertion. So what is insertion? Insertion is nothing but adding a new data item to existing data structure. For example, if there are 15 data items in a list or in a data structure, suppose if you want to add one more data item, then we can insert or we can add that particular element at any of the point, that is, or at any of the index. Deletion, the process of removing an existing data item from the given collection of data item is called deletion. What is deletion? It is deleting a data item from the existing data structure. For example, if there are 10 data items in a data structure, so if I want to remove one data item, one data item or particular data item can be removed from the data structure. That operation is deletion operation. Now, next one is searching operation. The process of finding the location of a data item in the given collection of data item is called searching. Searching means to look for a particular data item for different types of operation in a data structure is searching operation. Sorting operation. The process of arrangement of data items in ascending or descending order is called sorting. So what is sorting? It is arrangement of data items in either in ascending or descending order. That is sorting operation. Merging operation. The process of combining the data items of two structures to form a single structure is called merging. So it is combining the elements, both the elements of two different structures into one data structure is called merging. For example, if you have a data structure, for example, A is a data structure with 10 elements, B is a data structure with 10 elements. So we are going to merge those two data structures, and we are merge those two data structure into data structure A. Then data structure A will be having 20 elements. That is merging operation. Now let us look into one of the data structure, that is arrays. Now all of you know what are arrays. What are arrays? Arrays is a group of elements of homogeneous data type. The meaning is array is a group of elements of homogeneous. The meaning is all the elements of one data type. For example, if integer array is nothing but all the elements, elements or data items are of data type integer. Suppose if it is a character array or if it is a character array, then all the data items in an array will be of the data type character. So that is the meaning of it is a homogeneous group of elements, that is an array. Now we can see different types of array. That is, first one is one-dimensional array, two-dimensional array, and multi-dimensional array. These are all different types of arrays. Now let us learn the definitions and syntax for one-dimensional array. Now, what is one-dimensional array? First, the definition of an array. An array with only one row or one column is called one-dimensional array, and it is a finite collection of n number of elements of same data type. So, elements are stored in contiguous locations. Elements can be referred by index. Array can be denoted as data type, space, array name, and size. This is how we declare an array. Or if I say declaration, we are creating a data structure. Here, array is a data structure. So, array definition, we know it is a group of or collection of homogeneous elements, and here these elements either we can arrange either in one row or one column. That is the definition of one-dimensional array. So we can store the elements either in one row or one column. And here the data items in an array are called elements of an array, and all the elements are referred by index. And this is an example or syntax. How do we declare or how do we create a data structure array? With the syntax data type, space, array name, and size. And here size is it is a finite collection of n number of elements. Array will be having definite number of elements or with a definite size. For example, int is a data type, space, a is the name of an array, of size is 10. So here int stands for data type int, so it represents integer array. And for example, double space b of 10. So here b is the name of an array of data type double, so it is double array. And in the example, in the syntax, size, here we have given the size as 10. What is the meaning of that? Here, the size of an array is 10. So this is the maximum element we can store is 10. That is the meaning of it is a finite collection of n number of elements. Now let us see how do we represent one-dimensional array in computer memory. Elements of linear array are stored in a consecutive memory locations. For example, let P be the location of an element. Address of first element of linear array is A is given by the base A called the base address. Using this, we can calculate the address of any element or element of A by the formula this. See, this is the formula. With the help of this formula, it is possible for us to find the address of any element in an array. Generally, in computer memory, if you declare an array, the memory address of first element are stored in the computer memory. So by looking at this formula or by using this formula, it is possible for us to find out address of any data item in a computer memory. Now let us look at the example here. Now this is an example here. This is the name of an array. A is name of an array, and here this elements A, B, C, D is element. Here one-dimensional array, as I told you, either we can store the values either in one column or in one row. So here the index here 0, 1, 2, 3, 4 are index. Now in computer memory, all the elements are stored with reference to address. So for example, this is address is 1000, 1001, 1002, 1003, 1004. So all the elements of an array are stored in different memory address. And how do we index it here? 0, 1, 2, 3, 4 is the index. So here S0 is the index 0 stands for A, that is first element, second element, third element, fourth and fifth element. In this example, there are 5 elements. The size of an array is 5. So 5 element. Address of first element, how do we refer it? Our index of first element is 0. Here S of 0 means S is name of an array, 0 is the index. So S of 1, here S of 1 name of an array, 1 is an index. So S of 1 means the index 1, the value is B. And similarly for C, D, E. Now these are the memory address. In previous slide, we have seen the formula to calculate a memory address of any data item. For example, in this one, I would like to find out memory address of element D or index 3. So how do we, according to the formula, we can make out here address A of 3. This is, I would like to know the memory address of index 3, S of 3. So here data item is D. Now base address is B plus W is the word P minus LB. In this example, W stands for word, that is equals to 1, and here LB stands for lower bound. Accordingly, base address is nothing but address of the first element of an array. In this example, A is the first element, index is S of 0, and memory address is 1000. It is, we have taken it for example. So this is a base address is 1000 plus W is the word 1, and P is what the position what we are looking for. So index is 3 minus lower bound. Lower bound will be always 0 because array index always starts with 0. 0 is the first index. So 0 index means that indicate first element of one-dimensional array. So accordingly, that will be the lower bound. Lower bound is 0. When you simplify this, you will get the answer as 1003. So 1003 is the memory address of S of 3 or at index 3, or the data item D is stored under the memory address 1003. So this is one of the formula to find out the memory address of any data item in one-dimensional array. Now let us move on to another slide. Here, basic operations on one-dimensional arrays. Following operations are performed on one-dimensional array. First one is traversing. Traversing, accessing each element of an array exactly once to do some operation. So, what is the traversing operation? It is nothing but we have to access all the data items of a data structure or of an array at least once. And here, for example, for this, suppose if you write a program to enter values into an array and to print the values. So if you write a program that is an example for traversing operations, then we are entering values or data items for all the index, and once the values are entered, we are going to print all the elements of an array. So that is an example for traversing, where each data item must be accessed at least once for different operation. Searching operation, finding the location of an element in an array. What is searching? Suppose if there are 10 items, I want to know what is the data item, for example 5, what is the memory address, or what is its position in an array. Then for that we are using searching operation. So searching operation is used to find out the position or location of data items in an array. Next, sorting. Sorting is arranging the elements of an array in some order. Here, some order means either in ascending order or descending order. That is sorting operation. Insertion operation, inserting an element into an array. So, suppose if there are 10 elements in an array, suppose if I want to add one more data item into an array, it is possible with this insertion operation, or that operation is insertion operation. Deletion operation, it is removing an element from the array. So deleting existing item from the an array is deletion operation. Next, merging operation. What is merging? Combining one or more arrays to form a single array. It is combining the data items of two different arrays. For example, if A is one array and B is another array, so we can create one more array C by combining those two arrays A and B. So that will be the merging operation. So these are all different operations on one-dimensional array. Students, let us continue our discussion in my next session. Thank you very much.